Okay, so I'm just going to first move myself up to the place where I want. So I'm just going to spawn this bot that's really... Oh, this is a worm bot. This is not an RC bot. Okay. Work in progress, but basically this is just a demonstration that it can reach A to B. It's looking for me, so it gets to me. That's all. So here we're going to go over dynamic objects, which is a primary thing that has been developed in this next version of Worm. And yes, that's the primary reason why this has taken so long. Also, it's because, like I said, I've worked on it 4 weeks in the entire year of 2025, so you will probably not be able to play Worm, but your grandchildren will. So that's something to look forward to, maybe, if Half-Life is still around by then. But anyway, so here we have an adversarial setup. I have made this little level, and I made it sort of a challenging setup for the mesh generator, because what people might not know about Gold Source Engine is that the teleporters are not point entities. They are, which in Unreal Tournament, in Unreal Engine 1, they are point entities. In Unreal Engine 2, they are point entities. Here, they're actually volumes. Oh god, what did I do? Where's my other things? Where's my other windows? They're all gone. What did I do? No, okay. Anyway, as I was saying, so they're actually volumes. Now, here's the thing. In the BSP, you have this set up here, where you can manipulate volumes, particularly via rotation, which is not expressed in the entity object. However, look, if I do something like this, I can go right through it. I don't have the geometric information. The geometric information is not expressed in the entity object. So it's basically a limitation that unless I read the BSP file itself and interpret them, which could happen, could do that, yes. For now, we're not going to go that deep. So the extent to which Worm can figure this out is with the bounds, the rectangular bounds of this geometric object. And what that means is, like, I'll just give you an example. Like, the rectangular bounds around this is going to be like just this. It's going to be something like this. And it's going to be back here too. And it will be, and that'll be the rectangular bounds, is a rectangular prism that encapsulates the entire geometric object. That's the extent to which Worm can work with dynamic objects. So they could have strange shapes, very rare, but yes, it does happen. Some mappers are goofballs and weirdos. You'll usually see something like this. This is a normal teleport volume. It's just a cube. You touch the cube and then you get teleported. But you could have weird teleporters like this, where it's like I'm like walking underneath it and nothing happens, but if I like jump, then I get teleported because I'm hitting that. So the game engine has the geometric information, not necessarily the entity object that can be accessed. So that's the extent of dynamic object information that can be extracted without going too deep. So let's just load our mesh here that I already have. Just no nonsense, just a basic mesh. So what I'm going to do is I'm just going to force annotate this. Now, this is the annotation process. So we're to the point now. The update is you have the full navigation mesh, which is the .nav file, which is the navigation mesh itself. And on top of that is annotation, which is information about the world in addition to the fundamental navigation mesh that informs the agent how to better travel and interact with the world. So what that means is if I do this, annotate all 1 and 2, what did I just do? So now you see here that there's this rectangle. So what this indicates is that this is a dynamic object. You can actually move teleporters. That's the thing that people might not know. So Worm treats teleporters as dynamic objects. Will they usually move? Very rarely will they move. But you can move them. So they are treated as dynamic objects. Now that's for people that are looking for the exported version, not very important, maybe, because you're just going to export like what the annotation has done, which is this. So that's not important, but it is like for updates for eventually when like the actual bot is fully fledged. So basically, this is not saved in the nav file because it's dynamic. I'll think about basically making it static. That'll be like the next update, is to assume everything is static, as far as like teleporters and stuff, and then it'll be saved to make it faster. But for now, it's not going to be saved. It'll basically be like auto-detected. So for example, we're going to do boxes later. We're going to do moving boxes. So if I move a box here, so, theoretically, there will be this rectangle around it, and I can move it anywhere and around this, and there will be like these red segments. What these mean basically are, this is the way that this particular polygon is noted to be a dynamic polygon now because it has a dynamic object in it. So once an agent reaches this, the way it navigates around dynamic objects that can potentially move are these red segments, which are like visibility indicators. So it's not just about, okay, now that there's dynamic objects and stuff, I can't just move from A to B. I have to use these red indicators, which are visibility points to tell me where to move from A to B. So that's the main update. That's what's taken a while. So like, in theory, if I move the teleporter somewhere, these red segments will reorient themselves. They're really points here connected to each other. And if there are a bunch of boxes here, then there would be a bunch of red segments indicating like which way to go and everything around them, if possible. And there's also modifiers on the connections indicating whether you can even go. Like, say for example, if you added a box here across the whole thing, it would just shut down. It wouldn't be able to connect. And here is the same thing. See, this is telling agents that that's the intersection between this dynamic volume and the polygon. So in order to interact with the dynamic volume, when you're inside here, this is the area you can interact with. And so that's the primary thing. Okay, so what we're gonna do first is I set it to dynamic off. So I turned off dynamic detection. So we're gonna do a teleporter test here. We're gonna spawn the bot, and we're gonna see how it behaves. So we spawn it, And notice that it just went right through. And conveniently, of course, the teleporter got him to the location. But I put the location here, so this is where he wants to go, right? You want to find out the fastest way to get there. Now, consider that going here, teleporting here, and then going all the way over here, that's actually a longer path. Now, if we turn, we're going to turn dynamic detection on and redo that and see how it behaves. The bot's goal is the same location, right? So we're going to do that now. And notice that what goes around the teleporter, it knows where it is. So that's one thing. The other thing is that we have is teleporters. This is new in Worm, in this next version of Worm. Teleporters are integrated, so that's one of the entities. So now with dynamic detection on, I have set the desired location to be somewhere around here. So without dynamic detection, basically the bot is going to go over here. It's teleport and then like move over here, which is longer than going over here and just immediately getting to the location. So load ladder 2. So this time you'll notice I'm loading nav. I'm not loading SPL. I'm not using that because what's going to happen now. So this is the update is if there are auxiliary nodes, you're going to get a saved nav file rather than an SGD file because the nav file is the navigation mesh with annotation. So you'll notice here we have this new purple line. And what that means is it indicates a connection to this ladder. So this is the way that you would have an agent be able to climb the ladder. This is where you would go to climb it. Okay? And you'll have also this connection here. This is the node. It indicates here's the way to climb the ladder downwards. They're both connected. So that's the new thing. We have ladders now, and we have them also exported. So let me make sure. So if you do worm export mesh, then you go to here and you'll get new stuff that we'll talk about in a moment. So that's the other thing we have. We have ladders now. Okay, so in the JSON export, once you export it with worm export _ mesh, this is what you will get now. So we'll go over the new stuff. I already went over this. We already know this is old stuff. So this is like, for each node you have the geometry of the polygon, the vertices in other words. The connections, that's old stuff. So let's go through something that has a dynamic. Okay, so here for example, so here what you will have, yes, you'll have the geometry, you'll have the connections. Now you have an interior viz graph only if the node is dynamic, meaning it has dynamic objects intersecting with the geometry. And so if you have it, then that means you'll get a graph it's an internal graph, a bunch of vertices, and it's a point graph. And the point graph expresses how to get around the dynamic objects. So this is a list, an array of objects that have an ID, the ID of the vertex, the flags which should not be important to you at this point, and the coordinate location, and the connections, which vertices are connected to which vertices, right? And then you can ingest this and make an adjacency graph out of it on your own. So that's the first thing that's new. The second thing is, in addition to the nodes, now we have annotations. So in the mesh data, this is separate from the list of polygons that have a bunch of stuff. Separate from the mesh itself. The mesh itself is in nodes. Now we have this. What you'll have in here is collision objects. These are the rectangular prisms that encapsulate the dynamic obstacles in the navigation mesh. So you'll have bounds, which are the vertices of the rectangular prism. That's a list of vector of coordinate points. You have floor center. This is not important. That's just part of the JSON export, the object export. You'll have ent ID. Now, ent ID points to it's the ent index of the actual entity that is the obstacle. You'll have other ent ID dependent on what kind of obstacle this is. Since this is a teleporter, other ent ID is pointing to the teleport destination in this case. And it's pretty much always going to be like that up to this point. So you can assume that this ent ID, this is the other ent ID, that's like the teleport destination. So that's what you're going to have. So those are two of them. So that's the new stuff in the JSON export. So you have this new stuff. We're going to go over ladders in a moment. So let me copy that right now, actually. So ladders. Let's see if I can make this better looking. Okay, let's go here. Tree. Okay. So the next thing is you could have also in mesh data aux nodes. What's that mean? You'll notice here in this node connection, you'll have this new thing. It says AUX is true. What does that mean? That means this connection is pointing to an auxiliary node rather than a polygon, a part of the mesh. It's not necessarily part of the mesh. In this case, we're looking at a ladder. Okay, so in your version, you'll have the ID exported, and this older version is not showing. But in mesh data, there could be aux nodes, auxiliary nodes. These are different types of nodes. For now, we just have ladder. So here you'll have the face of the ladder, which is like all the surface that an agent can climb on of the ladder. And you'll notice that this, if you look at these coordinates, this is an upright face. This is not like a surface you can walk on. So this cannot be treated as just like another polygon necessarily on the mesh. And you climb it. It's a different kind of interaction. So that's what you get. You get the face of the ladder, which is the geometry, and the normal, which is pointing towards, it's pointing opposite to the way that an agent would be facing. So if an agent is looking straight at the ladder, intending to climb it, the normal will be pointing opposite that. So that'll indicate like which side you're supposed to climb on. I'm debating whether to include this. I probably will. So connections, this will include like here. So like for what I'm saying is like ID 17 is pointing to this ladder. This is the connection for the ladder. This will also be duplicated in here. So this will be like connection. It'll point to ID 1, the polygon in the mesh ID 1. So that will be in there in the version that is released. So that's the new stuff, the exported JSON. So that's the structure of the exported navigation mesh now. So what next after this? Okay. Next thing, stairs, which Probably should have been done like way earlier. Stairs are going to be done, and what you're gonna get is just a polygon. You don't have to do anything different with stairs. Along with some stabilization, it has become a little bit unstable. No thanks to the Sven Co-op devs who put their shitty crash handler thing so that my debugger is not able to attach so easily. In like 50 years or whenever next I start working on this,